Marcos, are you ready for your demo on how to use OpenLABEL?
Yes, let me then set the screen again. Okay, first of all, the idea is that the entire OpenLABEL project right now is about defining the recommendation, and therefore how actually any company or interested party can use it is really up to anyone. So it's not really defined in the standard how to actually, for instance, create labels. Nevertheless, for this slot, we will talk about our own experience. And of course, as OpenLABEL is under development, one of the ways to go right now is to showcase how OpenLABEL is, let's say, useful, is to create converters. And therefore, we have been creating a number of converters for different open source datasets, very varied, by the way, because as explained by my colleagues previously, we first want to focus on 2D objects, 3D objects, and semantic segmentation. And as a consequence, we went to the literature and found some open data sets and created converters for each of them, just to make sure that the OpenLABEL principles that we were discussing cover all these very different concepts, and therefore that JSON content can be created out of them. For that, of course, you need programmatic interfaces. In our case, we are using an open source software that we have been developing, which is the so-called VCD library. And in addition, we are developing as well an annotation tool, which is yet under development, but I will show a glimpse of how it is. So the first quick demo will just be to show how 2D labels can be created out of images, and then I will first show basically the converter that we can create using the VCD API about the town center dataset, which is a quite old but very nice dataset about CCTV monitoring. So I will just go to my PyCharm and execute a script which basically reads the town center ground truth data. Sorry, it's popping up in the other window. Yeah, and convert it to OpenLABEL. The idea is that this data set is interesting because it does have these nice properties that we want to include in OpenLABEL. Like each object is represented by two bounding boxes, sorry, head and body, and the ID of each of them, each of these persons is kept through time, and therefore we can draw this trajectory. It's a basic use case in literature, and this is of course well supported by OpenLABEL in its current form. So no big mystery here. How it looks like in when expressed as a JSON file, I have opened it here. May take a while because these files are in some cases huge, such as this one. So this is the JSON file of the previous scene. Sorry, yeah, it's minimized. So we have this basic stuff here, the OpenLABEL, the version, the frame intervals, telling us that there are 4,500 frames. So if we unroll this, we will have that many entries here that we could be inspecting one by one. But also we have the object level entries, which tell us how many pedestrians there were here. And if I'm not wrong, yeah, there are like 230 persons in the scene. And for each of them, basically we have the class, which in this case is just pedestrian, the frame intervals in which it is defined, and the data pointers. So we can take a look here and see in which frame intervals these particular bounding boxes were defined. In this case, and for these datasets, this coincide because always for all frames in which a person is defined, there is a head and a body label, but it could be the other way around, or it could be there could be some missing or gaps in between, and therefore these pointers are useful. So we could go to this frame, for instance, and look for pedestrian number 230. Yeah, there's a way to do so. It's basically jump into one of these frames over here, and under this frame we can see which objects were actually present at that moment. So there were quite a lot, as I can see. Yeah, I don't remember which one I was looking at. I think it was 230. Well, in any case, you can see that they are listed on here. And the only information that is represented here under this frame is the dynamic one. So all other information that we may have about this pedestrian, this person, is stored outside at the root level. Okay. Okay. Second example is the same concept, but in automotive as an automotive application. Let me first show you a quick video about how an annotation labeling tool may look like. Basically, it may represent the video file, also contain some buttons to add objects at the left, so that we can have a list of existing objects there, define their name, their type, etc. And in the horizontal bar, we can add of course, the time information. And the first example, we first define the time. We can move it by the frame intervals. As we have seen before, OpenLABEL supports having multi-frame intervals, so the same object could be disappearing in certain gaps and appearing again. And for each of the frames, as we can see, we can add different properties and stuff. Labeling is not a simple thing, of course. I guess everyone here knows, so that's why I'm just showing the video. And now I will open the tool where let's say the annotations have been already completed, because it takes some level of ability to use the tool and some time, of course, to prepare all the material. So yeah, let's skip this and take a look to the tool itself. Basically, it's I would say a regular labeling tool, just like any other. Which you may find everywhere, basically nowadays. As I said, you can navigate in time, in the sequence. You can also navigate in, let's say, object-wise. So if we click this object, we know in which periods of time it is defined. Something we have not been talking about that much today, and because it's left for subsequent releases of OpenLABEL, is the ability to label other things and not only objects. So we have objects here, of course, as the most interesting thing to label. In this case, bounding boxes in images. But we can also label actions as periods of time, where there is some semantic load defined, such as, in this case, we are defining actions such as driving straight or lane change. If I'm not wrong, in this sequence, there is a lane change maneuver carried out by the ego vehicle. So at the beginning, the ego vehicle is in the left lane. And when these other cars pass, the ego lane executes a lane change maneuver. And this is labeled here. So this is actually an action label. The very same way it will be as an object without object data inside. Events are just instantaneous items. So for instance, this is the event pass. That means that in this very same moment is when the last vehicle in the rightmost lane goes and pass the ego car. And it is useful to have this sort of annotations because they trigger actions typically, and therefore it's good to have them in a way to define the semantics of the scene in a time coherent way. Last but not least, interesting enough, is that the schema already supports also the annotation of relations. It's a complex thing, but it's interesting because this way we can relate actions and objects as triple triplets of with semantic load, such as we can say that the ego car is the subject of the action drive straight, and we can use here the annotation user interface to select which of the objects already labeled is subject of action or is related to any other action here. The point is that this annotation tool reads not only the OpenLABEL structure, but also potentially it can read the ontology that coming from the OpenX ontology can put here in the drop-down menu only those relations that are coherent with the type of the object here, because you may want to associate a car with a particular action and not with others because they might be related to pedestrians or things like that. For instance, a car cannot have the same type of human behaviors as a person, for instance. Okay, yeah, but this will be the subject for further extensions of OpenLABEL. The point is that the schema already supports most of it, but there has not been yet a sufficient agreement and discussion on how this type of complex things will look like, and therefore they are left for subsequent steps. Okay, sorry, move on. 3D objects. We have taken Kitty dataset. The reason is that it is, despite being quite old now, it was released in 2012. It was one of the first that contained multiple type of annotations. So the labels contain not only bounding boxes, but also 3D cuboids. And therefore, it's very interesting to see whether we can create a converter, which we did, to OpenLABEL. What we see here is, let's say, a painted view of what the OpenLABEL file contains in terms of information. So it does contain, let me try to pause. Yeah, it does contain instantaneous information of all the objects as a given frame. And as we explained before, the objects exist inherently as entities, and their representation is multiple. So we can have the representation under this coordinate system, which is the camera. So in the form of a bounding box, or if you see, we can see here also the 3D bounding box projected into the image, because this dataset was already calibrated so that we can have the projection matrices needed to project cuboids into this image, or to draw the information into the local coordinate system of the vehicle. So this is the ego car in gray, following the ISO 8855 coordinate system. And therefore, all other annotations can be expressed with respect to the local system or to a global one. So this is the ego trajectory. And as you can see, the ego car is following a road, following another car. There is traffic coming in front, etc. Sorry, jumping in. Yeah, of course, this is about converters, but definitely you want to have a labeling tool to label the 3D objects. This is just an example of one of the labeling tools we have. It is a playing video because I'm super bad annotator and I will mess up, of course. But the idea is that the annotation tool works on the point cloud level. So point cloud sequences can be presented into the tool just as the image sequences will be. And the annotator is given a number and a series of menus and UE functions to create bounding boxes, cuboids, polylines, etc. And as we saw before, the idea is that this information is added dynamically. That means that, for instance, the annotator is now drawing the shape of what seems to be a tree. And then at the bottom, we have a horizontal line, which represents the time dimension of the object itself. So that we could be adding all these properties in the bottom left to this element. And the attributes we want to include can be defined in a configuration file where we can have the dictionary of classes that we want to consider, so that the annotator doesn't need to actually type down any free text. So the classes are predefined, and therefore somehow you ensure that the final annotation files are correct. Yeah, let me show you an example of how a 3D object labeling file looks like. Just like any other OpenLabel file, we have an entry about the schema version, but also the coordinate systems. In this case, for the Kitty dataset, we have the world coordinate system, the vehicle, the Velodyne, the IMU, and cameras, right? Camera left and right, because it was a stereo setup. For each of them, we define the parent-children structure and the pose, or its pose with respect to the parent, so that we can know how to convert from one camera to, well, from one coordinate system to another. As I explained before as well, within each of the frames, for instance, this one or any other of your choice, we also have under frame properties the ability to express dynamic transforms. So this transform here explains that to convert from the ego vehicle coordinate system into the wall coordinate system, or ODOM. Yeah, ODOM means odometry, typically represents the world coordinate system. We have instantaneous transform to apply. So any geometry defined in the rest of the JSON file at this frame, if you wish to convert it to the from one coordinate system to the other, you just need to apply this transform. Also, as we saw before, we can represent this as a 4x4 matrix, but there are other supported versions such as quaternion, which is, by the way, the recommended approach, or Euler angles, as long as you define the sequence. Okay, and last but not least, sorry, where am I? Here. Yeah. Last but not least, the semantic segmentation stuff. The idea is that there are a lot of open source resources over there, such as the Cityscapes, or for instance, Mapillary Vistas dataset. And we did the same. We created a converter to convert from these images into OpenLabel, just to show that the OpenLabel supports the complexity inherently in this dataset. Very quickly, the idea is that this dataset contains the information in the form of PNG images, plus some configuration files which explain or match the color of the images with class name and some other attributes. And we can convert this into OpenLabel JSON files. There are three options here, because there are different ways to express semantic segmentation image. Let me show you very quickly. Maybe, Nico, I'm running out of time. I'm not entirely sure. Maybe.
No worries. You can continue.
Oh,
we're still a little bit ahead of time, so all good.
Okay, thanks. For instance, this ugly piece of JSON file, if we prettify it a little bit, yeah. This is exactly the same mapillary image labels version. This is the color version that we have seen before, converted or embedded entirely into the JSON file. So if we zoom out a little bit, you can see here a very big base 64 string that represents the entire PNG embedded within the JSON file. This might seem as an overkill, but in some cases, it's good to embed all information into the JSON file itself, rather than having the PNG file floating around in your file system. In general, this way you have only one file to take care of instead of two. Nevertheless, there are other options, and the other one is to create polygons. Expressing the same image as polygons have a clear benefit, which is you analyze the image once, and that means using maybe OpenCV or any other library to extract the contours out of the PNG image by using image processing techniques, and you write down the result as contours. The good point about this compared to the base 64 is that you have one more level of processing data here. We can have the objects with their own identifier, the class. The class is here, and the polygons. An interesting property of polygons is that, let me find one of them. Yeah, here. Is that you can have several polygons defining a single object. And that's because an object may have holes in the image. And in particular, in this type of very complex things, you may have shapes which may have holes or intersections with other things, but still being the same class or the same object. For that reason, in OpenLABEL, we have adopted the hierarchy definition of structures of several polygons, the same as defined in OpenCV. You may notice that the polygon data itself is an array of numbers, and these are just X and Y pairs of the points that define the contours. And the important thing here is that this is not really compact because, as you see, there are a lot of repetitions, and in particular for large images, such as in Mapillary, there are like 4 bytes used to express only one coordinate. And therefore, other approaches are also included into the standard. One of them is to use chain codes. Chain codes is about encoding these very large sequences of XY pairs into a chain code. Chain codes, for those of you familiar, is a way of encoding or compressing data losslessly so that you can have very compact representations of the same very large polygons in form of string arrays. Of course, this comes at the cost of some more computational cost, but it compresses quite a lot the JSON file itself. The idea is that OpenLABEL supports these 3 options because it really depends on your use case. You may be interested in saving some storage capabilities, or maybe to simplify your file system management approach, or simply to have the a detailed level of object level information. Last but not least, the Mapillary Vistas has a nice property, which is the instance level information. So it's not only class level. So each pixel of the image is not only associated with one class, but also each pixel is associated with one object ID. That means that, for instance, in this case, if we have 2 cars together, in the previous example, all pixels in this area, let's say, are labeled as car, and they are not differentiated as belonging to different objects. But in the instance level, sometimes called panoptic level information, these 2 cars are differentiated. So this one may have level 0 and this one level 1. This is encoded in this dataset as a PNG file with 16 bits depth. And we have done the same. We have a converter which reads the information, extracts the contours, and store them into JSON files, which mostly look the same as the one that I have shown before for the class level. The only difference is that the, actually this was the instance level. Yeah, let me show you. The only difference is the class here. So basically we can have instances here. Yeah, so this is an instance entry, and in the same file we can have class information. So this entry here is an object of type class, so it corresponds to the class itself of the object, while the other one corresponds to the instance. The reason being is that in Mapillary, there are like 2 different channels of information here. We know in any case that the ultimate goal of OpenLABEL is to support multi-dictionaries, but unfortunately there is not such open dataset as well, to the best of my knowledge. And therefore what we have done is let me jump here. we have let's say a prototype application where we can label semantic segmentation channels here. Very normal annotation tool, just like any other you may find out there. The only difference is that this already produces OpenLABEL files, as they are already defined in the ongoing standard. And I want you just to take a look here to this tab here, where we have like 3 tabs. One is objects, another one is dynamic static, and another one is vulnerability. That means that we can draw, because this is basically like a Photoshop or Paint level drawing tool. We can draw like 3 different images out of the same image. So we can have a semantic segmentation about objects, such as painting if this is an arrow or a person. But also we can have another layer which just classify pixels as belonging to dynamic or static things, or to other concepts such as whether the pixel belongs to something which is vulnerable, regardless it is a person or anything else. The point there is that it's possible to build a single OpenLABEL JSON file containing all these layers all together. So you can embed all this information into a single JSON file. It may eventually be quite large, but as I said before, there are different options to manage, depending on your use case. And that's it. Hope you like the demos. I'm happy to answer any further questions. Thanks.